How you doing, physics fans? Today we're going to talk about Newton's laws. Now, Newton's laws are found in chapter 5 of your textbook, and there are 3 of them. So let's start with the first one. The first one states, if no net force acts on an object, it will feel no acceleration. Now, there's a couple of key words you need to key in on when you're looking at this. The first one is net force. That means the net force means that there could be multiple forces acting on an object, but if the net of those is 0, then the object will feel no acceleration. So net is the first one you need to look at. It could mean 2 or 3 forces could be acting on the object, but if you take the net of all of those forces and if they equal 0, guess what? The object will not be accelerating. The second one is the word acceleration. Now, acceleration, remember, we're talking about speeding up or slowing down. So if an object is not accelerating, it can either be stationary or it can have a constant velocity, right? So it's not speeding up or slowing down, it is staying constant, and the acceleration is 0. Let's go to the second law. So the second law states that the sum of the external forces is equal to the mass times the acceleration of an object. For Newton's second law, we have a couple of videos to help you out with this one because this is a heavy application law. We're going to apply this a lot of ways and ask you to solve problems using Newton's second law. So the first thing to look at is the free body diagram that we have, the free body diagram video that we already have made for you. Also, we do an example problem with Newton's second law, so go ahead and check that video out as well. When you're looking at this, remember that I have vector hats here, so I know that when I'm summing these vectors, I have to break them into their components and sum components of those vectors. If you're curious or if you still have some questions about summing up vectors, go to our vector video. It can talk you through breaking down vectors, breaking them into their components, and then how you sum vectors when you're doing any sort of vector summation. So this one again, restated it saying, if I look at an object and if I add up all of the forces acting on that object, that's equal to the mass times the acceleration of that object. Now, let's go to our third law. So the third law states that the force on object A due to object B is equal in magnitude and opposite in direction as the force on object B due to object A. So when I look at this and I look at a third law, I see the equation tells me the force on A due to B is equal to the negative force of B due to A. So that one doesn't really tell us much, but let's kind of break it down and think about it, what we're saying here. So the first thing I want to do is I want to show you an example. So let's say I have a ball and it's resting on my hand. So let's look at each object individually. So this ball, as it's sitting here on my hand, is feeling a force from my hand directed upward. Now my hand, as it's sitting there with the ball resting on top of it, is also feeling a force. It's directed downward, the force on the ball is directed upward. If you look, those have the same magnitude, except they are opposite in direction. Now, two key things to think about when you're talking about Newton's third law is that they always come in pairs. So when you're talking about a third law, there has to be 2 objects interacting. In this case, it was my hand and the ball. The second thing is that it's the same type of force. Now in this case, in this example, the normal force was the force that was producing a third law pair, or a Newton, we were applying Newton's third law. It could be any other of the type of forces, and it always has to be the same type. That means that the weight force and the normal force cannot form a Newton's third law pair. The weight force and the tension force cannot form a Newton's third law. The normal force and the friction force cannot form a Newton's third law pair. So remember, it always occurs for 2 different objects or occurs in pairs, and it's always the same type of force. That concludes our video on Newton's laws, and we'll see you next time. You know what? That was way easier.